All right, Mr. Kelly, this is David Engell with quiz 16. The first question is about an airplane traveling horizontal with a velocity of negative 212, drops a package 366 meters onto a target below, and then you're looking for the delta S in the x dimension that it should be dropped in order to land it on the target. So you know a couple things off the bat: the initial velocity in the x dimension, you know the change in position in the y, you know the initial velocity in the y dimension, and you know the acceleration. So first thing you need to do is find the time. To find the time, you can do the square root of 2 length over a, which is going to give you 8.6 seconds, and that's going to be the same for both dimensions. And then after finding that, you can find the final velocity by multiplying the time by the acceleration, and that will give you 84.6 meters per second. The average between 0 and 84.6 is going to be 42.3 meters per second as an average velocity. And then your delta S in your x dimension is going to be your velocity times time, which is going to give you a change in position of 1,823.2 meters, and that is going to be where you want to drop the package before it reaches the target, blah blah blah. Number 2 asks what is the general equation, and of course it's going to be delta S equals velocity times time, but delta S in this occasion is going to be velocity times how you found the time, which is the 2L over A. So there is your general equation, or number 2. Number 3, you have your delta S and V and delta T and delta S and V, VF, V, A, delta T. And what you know right off the bat here is going to be your initial velocity in your x dimension and your change in position in your x dimension. This one is about the bullet that is fired at a speed of 225 and is at a target 62.6 meters away. How far will it travel before it? How far in the y dimension will it travel before it lands? So again, to find the time, we're going to take the distance divided by the velocity, and that's going to give us 0.27 seconds. And then that's going to be the same for the y dimension. Then we also know that the acceleration in the y is going to be negative 9.8 as usual. Velocity in the y initial is going to be 0, and the final velocity again is going to be the time times the acceleration, which is going to give us 2.64 meters per second, and average between 0 and 2.64 is 1.32. And then the average velocity times the time is going to give us the delta S equation, 1/2 AT squared, is going to give us a delta S that is equal to 0.37 in the y dimension, and that is actually going to be the general equation that we use to answer this question, since the original velocity is 0, so that cancels out. So the equation is going to be delta S equals 1/2 A, and then in place of T, we're going to put delta S over V, because that is how we initially found our T. So that is quiz number 16.